So, oh, my help if I turn my projector on. Okay, triangle similarity is going to be lesson 4.2. So it should say triangle similarity at the top, lesson 4.2. Make sure you're on the right page with me, please. That would be page 4. We're all on page 4. So we're going to go ahead and label this 4.2, triangle similarity. Lesson 4.2. Okay, triangle similarity. We proved that triangles were congruent in the last unit, and in this unit we're going to prove that they're similar. So triangles that are similar have the same shape. Let's go ahead and write this. They have the same shape, but they have different sizes. They're the same shape, but they're different sizes. Okay, so the first one we're going to look at, these look very similar, angle, 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 side, 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 angle, side. These look very similar to the way that we proved that triangles were congruent. Okay, but this time we're going to just talk about how they're similar. And if they're similar, that means we can set up some ratios and that kind of stuff, right? And talk about if they reduce to the same number. That's what we did in yesterday's homework. Okay, so if I'm looking at this, the first way I can prove that two triangles are similar is to prove it by angle, angle. If it says angle, angle, then that means I probably only have two angles that are similar. Because let's talk about this. If I know that 75 is congruent to 75, let's mark that. Then we know that 31 is congruent to 31. How would we figure out that third angle? Add the two of them together and subtract from 180. Okay, let's figure out how much that missing angle is. How much is that missing angle? I have one person that says 74. Another person says 74. A third person 74. Can I get two more that say 74? 1, 2. Good. Okay, so 74, we can put that in each triangle. So the rule states if two angles are congruent, then that third pair has to be congruent, right? Because we only have 180. Yes? So yeah, I added 75 and 31 together, and then I subtracted that from 180, right? Because all three angles in a triangle make 180. And that whatever amount is left is how much that third angle is. Okay, so we would say that these two triangles are similar because at least two angles match up. Because if two angles match up, then that third one is also going to match up. They are the same shape, but they are not the same size. So we would say, yes, these two triangles are similar by angle, angle, similarity. And then it says, if they are similar, write a similarity statement. So a similarity statement means matching up the angles with the correct angles. So if I said triangle ACB is similar to triangle what? What would you say there? If I said ACB, DFE, and it must go in that order, right? Angle A matches up with angle D, C matches up with F, and B matches up with E. So DCF. Good. Okay, so let's look at the second group. DFE, I'm sorry. Sorry. DFE. Excuse me. All right, so let's look at our second group. We have one pair of angles that are already marked, right? So what about, is there a second pair that could be marked? Is there a second pair that could be marked, James?
Angle X.
Angle X, what kind of angles are those?
Vertical.
Vertical angles. Do you guys see that these are vertical angles? Right? So even though I don't have an angle measurement, even I don't know that they're like 20 degrees or 50 degrees or whatever, I do know that they match up. So now I have two pairs of angles that match up, and that's enough to say that these two triangles are similar. So we can say yes by angle, angle, similarity. And you need to put the similarity symbol because when we get into side, 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 and side, angle, side, that can be similar or congruent. So you want to make sure that you're specific. And now if I say triangle, if I said, whoops, VWX, VWX, that's similar to which triangle? If I say VWX, match it up on your paper. VWX. Natasha, you want to give it a shot? YZX. Does anyone agree with Natasha? Good, because we matched up V and Y together, and then we knew that we went to W that didn't have anything on it, so then I have to go to Z that doesn't have anything on it. Okay? Are you guys okay with matching them up? Good. All right. Okay, the second way that we know that two triangles are similar is by side, side, side. And if we're going to use side, 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 someone read that out loud to us. Ashley, can you read out what the definition of side, side, side is?
If all corresponding sides are proportional, then the triangles are similar.
Okay, I'd like you to box that word proportional. If all corresponding sides are proportional. That means that all the sides mark up to be the same scale factor. And we practiced that yesterday. So first, it looks like side, 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 right? Because I have 3 sides given. But this is how we need to make sure we match them up correctly because they're not always going to look neat and nice like this. We're going to put the small side over the small side. Then we'll put the medium side over the medium side. And the large side over the large side. And I'll show you what I mean by that. So I always like to start with the smaller triangle. And if we look at this one, PQR is the smaller triangle. Would you guys agree with that? Okay, so in triangle PQR, what's the small side there? The smallest side in PQR is what? 3, right? It's PQ, it's 3. So I'm going to write 3 over, and what about in triangle TSR? Or STU, sorry, not R. STU. What's the smallest side? 6. Those are going to go together. Then what's the medium side in either triangle? Remember, you started with PQR, so that has to go on top. What's the medium side? 4. Over the medium side in the other one is 8. And again, we started with triangle PQR, so that one has to go on top, and we're going to put 5 over 10. Now, if I reduce all of these fractions, am I getting the same number? What is 3 over 6 reduced to? 1/2. 1/2. What is 4/8 reduced to? 1/2. What about 5/10? Okay, so do you guys see that they have the same scale factor? Okay, so because this is the same scale factor, and I'm just going to put SF, because all 3 of them have the same scale factor, then these triangles are similar. So I would say yes. I know I didn't give you very much room to write. By side, side, side similarity. And then maybe up top we'll write our triangle similarity statement. And here's my suggestion. When I'm writing my similarity statement, I would always write small, medium, large. Okay? So if I have to go past the small side, that means I'm going to start at Q and go down to P, then to medium, then to large. You guys see that? So I would say triangle QPS is similar to which triangle? What? Oh my gosh, what is wrong with me today? It's Thursday. Okay, QPR, thank you, is similar to triangle what? Be careful. T down to S over to U. because you have to go past the small side, then past the medium side. So triangle TSU. All right, why don't you try number 4 on your own? Set them up small, medium, large. Keep the same triangle on top. And if the fractions aren't coming out nice, you can use a decimal. So 24 over 30 reduces to what? 4/5, which is what as a decimal? 0.8. Okay. What's 25 divided by 32? What'd you say? 0.8. Are you rounding? Don't round. What is it? 0.78. Don't round on these. I'm glad you brought that up. We don't want to round on these. They have to be exactly the same number. And then 28 divided by 35, what is that? 0.8. Okay, so when I'm checking to see if it's the same scale factor, again, Katie, I'm glad you brought that up. We do not round because they have to be exactly the same. Think about if you're building a building and the wood cut is off by 0.2 right? It's going to make a huge difference. It is. Okay? So, because they are all three not the same scale factor, that one messed them up. These are not similar. These triangles are not similar. And so you can just write not and then your little similar symbol. Now, here's something important to remember. It looks like side, side, side because I have 3 sides, right? So it looks like the temptation is to just automatically say side, side, side. It cannot be side, side, side unless they are all 3 the same scale factor. And you have to do a little bit of work for that, okay? Questions on side, side, side? Okay, side, angle, side. Carla, can you read side, angle, side, please?
If 2 corresponding sides are proportional and the included angles are congruent, then the triangles are similar.
Okay, I'd like you to highlight the word sides are proportional, and then I'd like you to highlight included angle. So just like side, angle, side congruency, the angle has to be in the middle, and the angle has to be congruent. So if we're looking at number 5 at this example, the angle is in the middle in between each of the 2 sides on each triangle. You guys see that? Okay. Now we have to set up our proportions because I can't just say, yeah, it's side, angle, side. I have to set up my proportions. So I only have 2 sides, so I'm going to have a small and a medium side, or small and a big side. So let's start with the smaller triangle, 6. And 6 is going to go with what number, Ben? 8. Then I have 15. 15 is going to go with what, Courtney? 20. Now you can use your calculator. 6 divided by 8. Or you can use, you can reduce your fractions if you want to. What is 6 divided by 8? 3/4 or 0.75. And then 15 divided by 20, also 3/4 or 0.75. So they have the same scale factor, and the included angle is congruent. So these two triangles are similar by side angle side similarity. And if I said triangle MNP, what would you say? Write that on your paper. If I said triangle MNP, James, what would you say? Triangle JKL. Does anyone else agree with JKL? I do. Good. All right. Why don't you try number 6? Number 6 can be a little bit tricky. Let's make sure we know what we're talking about with the two triangles. We have this little guy here is one of my triangles. And then I have the big triangle. Okay. Do you guys see any angle there that's marked congruent? Because it can't even be side angle side if I don't have an angle. Do you guys see that both triangles share this angle up top? You guys see that? Or at the bottom, whichever you want to call it. They share this one, and then so would the bigger triangle. They would share that. That's called a reflexive angle. So we've talked about the shared side as a reflexive side. So if they share an angle, that's a reflexive angle. Okay? So we know that the angle is the same, so we don't have to worry about that. Now we need to set up our sides. Okay, so why don't you see if you can set up your proportions for your sides. Bless you. Okay, so 12 goes with 21, and 15 goes with 25. So let's see if they reduce to the same scale factor. And you're using your calculator. Trinkle, what is 12 over 21 reduced to?
Mine says 1 3/4.
1 3/4. You can also hit this. There you go, 0.6. 15 over 25 reduces to 0.6. What about 12 over 21? Donald, what does 12 over 21 reduce to? 0.57. If we rounded, it would be the same thing, but we're not allowed to round. So are these the same scale factor?
No.
No. So are these triangles similar? No. So we would say not similar. And you can tell me different scale factors. They're not similar because they have different scale factors. Okay, any questions on this? This page is going to be a good reference. Any questions? These are the only 3 ways that we can prove that triangles are similar. Angle, angle, side, 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 or side, angle, side. Okay, so let's do some examples. Here we go. It says, are we similar? All right, so the first one looks like what? What does it look like? Just first glance. It looks like side, angle, side, right? I have the angle in the middle. So we need to check our sides. So that's the first thing we're going to do. So let's go ahead and check our sides. Match them up. Small goes with small. Medium goes with medium. So I would say they both reduce to 1/3. You guys agree with that? Okay, Okay, so that means that the sides are proportional. And guys, you have to show me this in your work. This is showing your work that they have the same scale factor. Okay? You can't just say yes and assume it to be true. So we can say yes, side angle side similarity. And then we need to write a similarity statement. So if I said triangle EFG, you write down the matching one. Triangle EFG. Ben, what would you say? RTS is correct. Good. All right, number 2. What does number 2 look like, Kyle? Just glancing at it.
Side, side, side.
It looks like side, 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 right? I don't have any angles marked. I can't just mark things. So it looks like side, side, side. And we check side, side, side by checking up all 3 sets of proportions. Put small with small, medium with medium, large with large. Take a minute and put up your proportions. I always start with a smaller triangle, so I would start with LMN on the top. Natasha, what are you finding? They're not similar. They don't have the same scale factor. Is that what you guys are getting? Okay, I think the second 2 are the same, I think, right? But the 16 over 22 is not. So these are not similar. And guys, writing your scale factors down here is proof that it's not similar, okay? So you're proving to me that it's not similar by reducing them all to the same scale factor. That's the work I'm going to look for to see if you understand what you're doing, okay? All right, let's do number 3. Okay, which one does it look like at first glance, Katrinka? Angle, angle, side, or side, side, side? Do you have any sides marked in this one? Yeah. No. So it can the only option would be, good. The only option would be angle, angle. Okay, and what do we know about vertical angles, Trinka? Like if this one's 42, what else is 42? The one across from it is also 42, right? Okay, and now I need to find that missing, 53 and 85 don't match up, but each of those triangles has a missing angle, right? So I need to figure out how much that missing angle is in each of them. So I can add them up and take them from 180 to figure out how much they are. Or Tensia, how much is angle E? 85. Anyone agree with that? 85 for angle E? Okay. Which then means that 85 and 85 match up. Right? They have to match up. Yeah, because remember, any 2 angles, if we add them up and subtract them from 180, that's going to give us the third one. Excuse me. Okay. So do I have 2 pairs of angles then? Okay, so this can be angle, angle. I don't really have to find out what D is, but I know that it's 53. So I would say yes, angle, angle, similarity. And if I said triangle BAE, beg. Okay, if I said triangle BAE, how would you match that up?
I'm lost. Okay.
Donald, how'd you finish this one? Triangle BAE is similar to what? BDC. I would agree with that. Triangle BDC. Okay, let's look at number 4. Number 4 we have to be really careful about. It looks like maybe it could be side, side, side. What other way could we prove this, maybe? Side, angle, side, right? Because Natasha remembers that this angle is reflexive to itself. So we could say side, angle, side, which is going to be one less set of proportions that I need. But if it's similar by side, 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 then it's also going to be similar by side, angle, side, so it doesn't matter which one you choose. Okay, so let's do this. Let's do 15. And then we need to figure out how much these sides are, right? 15 and 5 is 20. And then over here, this whole side is how much? 6 plus 18 is 24. So 15 is going to go with 20. And then 18 is going to go with 24. We don't even need to worry about that other side, because if these two match up, then it's a side angle side. Okay, so let's check. 15 over 20, that reduces to 3/4. And 18 over 20, if I divide both of those by 6, I also get 3/4. So are these similar? Yes. So let's say triangle, well, we'll say angle, side is what we used. Whoa. Side, angle, side. And then triangle PXY is similar to triangle what? If I said PXY, you would say PQR. Perfect, Lexi. PQR. Okay, just one more example, and then we'll finish this lesson. Okay, example number 5 is a little bit different because we haven't seen something with parallel lines. But when we have parallel lines, we need to look for specific types of angles. If you look at number 5, there are no sides marked, right? So it's going to have to be angle, angle if it's anything. Do you guys see here that if I have these two lines that are parallel, this right here would be the transversal, okay, which would make this angle and this angle match up, but that doesn't help, right? This one here and this one here, because that doesn't help with this one. Whoa. Sorry. That doesn't help because this one's outside, right? This guy that I just pointed to. Okay, so that one doesn't help me at all. Okay. What about these two lines that are parallel? What if I use this as the transversal? What do I know about this angle and this angle right here? They're corresponding, right? They match. One's inside, one's outside. Okay. That works. Okay, anything else that looks like it's going to match up? James?
Angle K of triangle JKN and angle L.
So you said this one here
Yep.
and this one here. All right? Because we have these lines that are parallel, right? And one's inside and one's, I'm sorry, not that line. This line. One's inside and one's outside. Good. So I have two pairs of angles that match up. If I have two pairs of angles, is that enough to say angle, angle? Yeah, it is. So we can say angle, angle, similarity, and then we will say triangle. I butchered this. Let's say KLM. Triangle KLM is similar to what? Go ahead, James.
JKN.
JKN. Good. You all right? Okay, any questions on that? The rest of them are the same kind of thing. Okay? Let's look at this homework, and I'll tell you which ones to do on homework 19. On homework 19, I want you to do (5 through 12). I want you to do 5 through 12, and then I want you to do 15 and 16. 5 through 12 on homework 19, and 15 and 16. Okay, I'm going to give you a few minutes of class time to work on this, and then we'll do our next lesson.